Alright, in this video we're going to go over the triangle inequality theorem. Now, what the triangle inequality theorem says is that the sum of any two sides of your triangle must be greater than the value of the third side. Now, it helps to provide some pictures and examples like this because this word jumble could be exactly that. It could be word jumble in your brain. So, looking at a picture right now, we have our potential triangle here, and it says that if we add up any two sides of our triangle, any two sides, no matter which two sides we decide to add, it has to be greater than the value of the third side. So for example, let's say this is my triangle and I decided to add up sides A and B. If I decided to add up sides A and B, I know that that sum has to be greater than the value of the third side. Now in this case, if I'm adding up sides A and B, my third side is C. So I know if I add A plus B, it has to be greater than C. But notice that it says the sum of any two sides, right? So I just chose to add up sides A and B. But there are other combinations that I can use. Another combination that we might see, instead of adding A and B, let's test it out if I decided to add up sides A and C. If I add up sides A and C, then in this case, my remaining side here is B. So again, if we go to the theorem, it says the sum of A and C, the sum of these two sides that I'm choosing, has to be greater than the value of my third remaining side, which is side B. Now there's one other combination that we can use. So we already added up A and B. We already added up A and C. The only other combination that we didn't address yet is this third one right here, where we are adding up sides B and C. Now if I'm adding sides B and C, my remaining side is side A right here. So now if I add up sides B and C, it has to be greater than the value of my remaining side, which in this case is A. Now, it's hard to kind of figure this out when we're just dealing with letters, but this concept of creating, you'll see that we have three inequalities created here, right? Now, this concept of creating three inequalities is going to hold for any type of example that's related to the inequality theorem. So we're going to go over the two different types of questions that you might be asked. So type 1. You might be given three possible values for side lengths, and you might be asked if they would successfully create a triangle. So for these type 1 examples, you have to make sure the theorem holds true for all pairs of sides. Now this is why we are creating three different inequalities, because we saw that in the other slide, there are three different pairs of sides that you can add up, right? So we have to account for all three of those pairs. So in this case, we're going to make three inequalities and make sure they are all true. If even just one of them is false, then the triangle cannot successfully be made. So type 1 example, can the following side lengths, or can the following represent side lengths of a triangle? So we have a set of sides. You might see it written like this. This just means that we have a side of 6, a side of 5, and a side of 2. So typically, when we are writing sides of a triangle, you might see it like this, right? Where A, B, and C are just the values of three different sides. So our first inequality, remember, we want to make sure we have all three combinations. So the first combination I'm going to talk about is 6 and 5. Those are the first ones that stand out to me. So if I add up sides 6 and 5, my remaining side is 2, right? So we know that the sum of any two sides has to be greater than the value of my third side. Now, before I solve, or before I check if it's true, I'm going to just go to my next combination. So we already did 6 and 5. Now I'm going to go to the right side and deal with 5 and 2. So if I add up 5 and 2, that should be greater than the value of my third side, which in this case is 6. And then my third inequality, the one that we did not deal with yet, and maybe we should be doing this in different colors. So we'll keep 6 and 5 in red. We'll do 5 and 2 in blue, and then the last one we can do in green. So inequality 3 would be adding up the first and the last numbers. So if I add up 6 and 2, it should be greater than the value of my third side, which is 5 in this case. Now let's just go through and check that they are all true. And if they are all true, then we are good to create a triangle. So 11 is greater than 2. This is definitely true, so I'm going to put a check mark there. Now 5 plus 2, is that greater than 6? If I simplify, I'll get 7 is greater than 6. That is true, so I'm going to put a check mark there. And then last but not least, 6 plus 2, is that greater than 5? If we simplify, we get 8 is greater than 5. That is true, so we are good. So the answer would be yes. These side lengths can actually represent a triangle because the triangle inequality theorem holds, right? Because we took the sum of any two sides. At any time we did that, that value was always greater than the value of the remaining side. All right, so type 2 example. In this type of questions, we are given two values for a side length, and we are asked for a range of values for what the third side could be. So for this type of example, you're going to have to make a set of values first. Now, side length 1 and side length 2, these are going to be given to you. C is just going to be the missing side that we're trying to find, right? So then again, after that, these next two steps follow from our type 1 example. So we're still making three inequalities. We're still going to solve all three inequalities. But in this case, we might get one with a negative value. In this case, we're going to omit that. And then I'll talk about the last two steps. So let's just go through the first couple of steps for a type 2 example. So it says, given that two sides of a triangle measure 2 and 8, find the possible range of the values for the third side. So for the first step here, we have to make a set of values. So this set of values, my first given side length is 2. My second given side length is 8, and then we're trying to find a possible range for the third side. So the third side we're just going to call C. You can really call it any letter you want. I'm just calling it C because, I don't know, I'm used to that. You could call it X or whatever you want. So now we're going to create our three inequalities using this set. So if you remember before, we had three given numbers in our set to make our inequalities, and now we still have three items, but one of them is just a variable, which is fine. So our first inequality, let's do this in purple. We're going to talk about adding the 2 and the 8. So if I take 2 plus 8, that should be greater than the value of my third side, which in this case is C. Our second inequality, let's deal with this 8 and this C right here. So if I add 8 plus C, that should be greater than the value of my third side, which is 2. And then last but not least, we have to add the first, or deal with the first and the last of this set. So if I do 2 plus C, that should be greater than my third side, which in this equality we have 8. So now, when we solve these inequalities, you want to solve, you're pretty much treating the inequality symbol, the greater than symbol, as an equal sign. You just want to isolate our variable here. So in this case, in inequality 1, we already have our variable by itself, so we just have to simplify. So here we have 10 is greater than C. Now in blue, we don't have our C value or our variable by itself. So what we can do here is subtract 8 on both sides, and we would get that C is greater than negative 6. And then lastly, in green, again, we have to get our C by itself. So we're going to subtract 2 from both sides, and we would get that C is greater than 6. Now, this third step here of our process, where it says we're going to get one with a negative value. In this case, we have to omit or reject that solution because you can't, remember, C represents a side length of a triangle. You can't have a negative side length of a triangle. So this negative piece is messing us up. So we're just going to literally write the words omit or reject next to that solution. And you can even draw an arrow to that, right? It's showing me I am not considering this in my solution set at all. But the two conditions that we do need to consider are these two right here. So in words, what we're saying is that our third side C has to be less than 10, but greater than 6, right? So if you guys remember how to combine these, you can write it in words. Sometimes questions will accept that. So I know C is less than 10, but greater than 6. You can write it out in words, or what you can do is actually write an inequality. So C is going to go in the middle. Your side will always go in the middle. I know I need to be less than 10 and greater than 6. So either of these would suffice in your answer here. Now, that means that your side can be anything in between 6 and 10. It could be 6.1, it could be 6.2, it could be 7, it could be 7.5, it could be 7.99, it could be 9.8. Anything in between these two values would suffice. All right, awesome. So you guys can use this checklist whenever you are trying to solve these problems involving the triangle inequality theorem.